Okay, just going to run through what bivariate data is. So bivariate data is basically when you compare two pieces of data. The word bi means two. So for example, your arm span and your height, like the one we did in class. You could have shoe size and height. Okay, so see how they're both times there's two pieces of data. Your running time and the distance that you run. Okay, something that is not bivariate data. Okay, so maybe when you just collect the time taken to complete your homework. That wouldn't be bivariate data because there's only one bit of information. If you decided to compare the time taken to complete your homework to the number of tasks completed, then that would be bivariate data. So you could, let's just say we collected data, we collected the number of scores, the number of goals scored in a soccer match by each player. So we're interested in the number of goals scored in a soccer match by each player. So once again, we're just collecting one piece of data. We're not comparing it. It needs to have two pieces of data. So that's why this one is bivariate, that one's bivariate, that one's bivariate, and these two aren't. Now, with bivariate data, like the data, let's just look at this one, and this one that we have up here. So with that sort of data, if the relationship is increasing, it is positive, then when you actually sketch it, you will have a positive gradient or a positive slope. Like if we look at arm span compared to height, then if we want to see if that has a positive relationship, then what that would mean is that if I increase the arm span, like when I collect the data, if there's an increase in the arm span, then that means that there's a change also in the height. In this case, there would be an increase in the height. Okay, so as your arm span increases, your height increases. And there's actually quite a strong relationship with this. And see, that would be an increasing data. It would have it has a positive gradient. So the relationship here, it would have a positive relationship. Whereas you did something like the time spent training, and you compared that to, so let's say training for the 100-metre race and the time to complete 100 metres. Okay. So if you think about that as the time spent training increases, then what will happen to the time in the 100 metres? Well, the time to complete 100 metres would actually decrease because you're getting faster. And when you get faster, the time decreases. Like, you know, some of the runners in the Olympics, got, you know, around the 10s and late 9s to run 100 metres. So we say this would have a negative relationship or a negative correlation, and, you know, it will be decreasing. And if it was drawn, does have quite a strong relationship, then the more time you spend, the more the thing's going to decrease. So you'd expect your dots to be going down instead of going up. And that's a negative relationship, whereas this one's going up and it's increasing, and that is a positive relationship. Okay. Just one other thing in our definitions, that's your independent and your dependent. Now, the independent is what you put in. So it's always your starting value. And then it is also on the horizontal or the x-axis. Whereas the dependent depends on what the x is, depends on the axis. So it is like the y value or the vertical axis. Okay, so whatever you've got down there, like if you had arm span there and your height there, then the one down here, this one here, that is called your independent, because that's on the horizontal axis, and this one here, this is your dependent, because as you do something to the arm span, then the height will increase, and that's the relationship between these two things. If you had a table of values like x, y, the top one would be what you're putting in, so that's your independent. The one that comes out would be the dependent. We often say the dependent is the thing that you measure, you know, or you calculate after you've looked at the independent to see if there's a direct relationship between these two things.